Hi there. More of our quality time together today, learning about multiplying and dividing logs, incorporating the power rule, expanding condensed logs, and you are going to like this change of base formula that I'm going to introduce to you. This is lesson 8.5, and before we get started with our notes, I want to talk about something you already know, which are 4 basic operations of math. We can add, subtract, multiply, and divide. If I asked you to put 2 of these together, pair them up, and create 2 pairs, which operations would you put together? Which ones logically seem like they should go together? Now, I would think that addition and multiplication would be paired with each other, and subtraction and division would be paired with each other, because multiplication is a fast way to add, and division is a fast way to subtract. So let's keep that in mind as we do our notes today and learn about 8.5, properties of logs. You can abbreviate that if you'd like. We're going to start with the product property. And just from what we just said previously in the last flip chart, what do you think would fill in the blank here? Multiplying transfers to what operation when it comes to logs? Addition. Correct. It transfers to addition. So when we think about multiplying with logs, we're going to already, in our brain, we've got it going that we're going to use addition. So let's start our first, here's our first rule. Log base b mn is the same as saying log base bm plus log base bn. And you can see here that this is m times n, right? Well, we took that multiplication and we replaced it with addition. That's what we're going to do when we work out our logs. So let's get an example of that. Example 1. If I have log base 94y, what's another way that I can rewrite that? What we can do is go ahead and take that and pull it apart and do a log base 9,4 plus a log base 9y. Simple way that we're going to rewrite that. That's all there was to that. Next example. What if I had log 615? Now think about this. How can I break apart that 15 so that I have factors that I can work with? Create some factors. And that would be if I had log base 6. How can I break that 15 apart? Maybe 3 and 5? 3 and 5. So I can do log base 6, 3 plus log base 6, 5. That's it for multiplying logs. That's our start with that. Let's move on to division. What do you think is going to come into play when I have division? The division transfers into what property? What basic function? If you are thinking subtraction, you would be correct. Subtraction. Here we go. And there's your rule for you. Log base b, and that's m divided by n, right there, equals log b of m minus log b of n. Let's get an example. Example 1, log base 5, 7 over 8. We can simply take that and we would have log base 5, 7 minus log base 5, 8. So once again, division became subtraction. That's all there is to that. Next example. If I had, and so you try, if I have log base 4, 2 divided by 3, how do you think I would write that? Go ahead and press the pause button and come back to me and I'll have the answer for you. So the answer there is log base 4, 2 minus log base 4, 3. How'd you do with that? Good job if you got that right. Moving on, we're going to go to the power rule. Power property is a real easy one for us to get a handle on because all you simply have to do is when you have this log base b m to the p power, you simply have to take that p and move it to the front of the log. That's all there is to the power property. So you can see here that I moved the p to the front of the log. So when I have an example like number 1, log base 5 x to the third, to write that, I simply have to take that 3, put it in front of the log, and then everything else just gets written the way it was. And there you go. That's your answer for example 1. And the next one, if I have a log base 6x squared y to the 7th, that's a little bit trickier because we're going to incorporate 2 skills here. We're going to use the first one with multiplication means addition, and then we'll incorporate the power rule. Because remember that this really means x squared times y to the 7th. When they're side by side, that implies multiplication, right? So in logs, what does multiplication transfer to? Multiplication transfers to addition. So log 6x squared plus log 6y to the 7th. Then all you have to do after that, after you get the addition, is you're going to take your power rule and transfer all of those to the front. So it would look like this. 2 log 6x plus 7 log 6y. And there you go. So just to recap that, we had multiplication here, we transferred it to addition, and then when we were done with that, we took our power rule, put it into play, and put that in front. And that's all there is to it. Okay, let's see what we got on this next slide here. Ah, look at this. Time for a joke. I figured maybe you needed a little break here, so let's see what this joke's all about. Where do you find the world's biggest spider? Think about that. I bet you got the answer to it already. In the World Wide Web. Ha, 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 ha. Okay, move on. Here we go. Okay, now if I give you some values for logs, like log base 5, 3, and that should be approximately is what I really want here. So just change that congruency, you remember that from geometry, to approximately. So log base 5, 3 is approximately 0.683, and log base 5, 7 is approximately 1.209. Okay, so with that in mind, let's see what we can do with something like log base 5, 3 divided by 7. All you have to do is use it's division, so use your subtraction rule. So log base 5, 3 minus log base 5, 7. Isn't this great? Because I know the value of log base 5, 3, and I know the value of log base 5, 7. So just incorporate this 0.683 minus 1.209, compute that, and your answer is negative 0.526. Okay, on this next example, log base 521, since we have the value of a log 3 and a log 7, is it real obvious to you that we're going to break down that 21 to be 3 times 7? What do you think of that possibility? So if that breaks down to log base 5, 3 times 7, how do we write that? We write that as log base 5, 3 plus log base 5, 7. And there's your answer. Okay? And then we go ahead and plug in that value of 3. What does that equal? Now that we're at that point, we would get 0.683 plus, this time, we're going to add this, 1.209. And what does that equal? That equals 1.892. Now I'd like you to try one. So here's your you try. Go ahead and try log base 5, 49. Press the pause key when you're finished. Come back and see if you got the right answer. Okay, let's see how you did with that. Did you break it apart into the two 7s and get 2.418? If you did, good job. Moving on. We have expanding log expressions, applying all the rules that we just learned today and see what we can do when we put them all together. So we see in the problem, we see that we have some division here. We see the division bar. And then we also see that we're probably going to use the power rule. So we have two different situations that we're going to address and work out. So let's do the division first. Let's see what happens when we break that apart. We'll have log base 9c minus log base 9d to the 6th. So now we have to address that power rule, and we simply have to take that 6, move it to the front, and so we are going to get log base 9c minus 6 times log base 9d. And that's our answer. Let's try another one and see what we've got for example 2 here. Log base 2, 7x cubed divided by 5. Alright. Pretty much the same as the other one, except you do have 7 times that x right there. You have 7 times the x to the 3rd, so it looks like you're going to incorporate some addition here. And then you've got that division sign, which means you're probably going to incorporate some subtraction. And you also have that 3, which means you're going to be using the power rule. So look at how pretty that one is. Let's get started. So this is going to be log base 2, 7 plus log base 2x to the 3rd. And I'm going to go ahead and make that division subtraction. So I put 2 steps together here. Log base 2, and that is a 5. Okay, and now I simply have to do one more thing here. I have to take that 3 and put it in the front. So rewriting everything else with the exception of that 3, I'm going to have log base 2, 7 plus 3 log base 2x minus log base 2, 5. And that is our answer right here. And this was our answer up here. And so how about you try in this next one? Try that problem, come back to me when you think you have it all worked out. And I want to give you a little hint here that you do not want to change that ln to log base e. No need to do that. Just keep the ln in the problem. So what'd you get there? Did you get ln 3 plus 4 ln y minus 3 ln x? If you did, great job. Very good. Alright, let's take a look at our next slide. I think we're going to condense now. One more example is what we have yet to go on example 3. I wanted to do this one with you instead of making it a you try because there's two ways that you can handle it, and I wanted to help you get to the easy way so your brain, when it sees this problem the next time, knows to just distribute this 1/2, right like that. And if you do that, this problem is a lot smoother and faster because 2, that's actually going to be 2 times 1/2, and that equals 1. We don't put the 1 there because it's understood. 6 times 1/2 is n to the 3rd. Look at that. And now all we have to do is use the multiplication rule, which will make this problem fold out to log base 8m plus log base 8n to the 3rd. And the last thing I have to do is incorporate that power rule. So you'll get log base 8m plus 3 log base 8n. How'd you do with that? Did you think it would play out that way? Take a look at that. Now, let's assume that you didn't approach the problem that way, that your eyes saw that 1/2 going in front of the log like this. Let's assume that you saw that move first. What would happen if you did that 1/2 log 8m squared n to the 6th? Well, you would just have to be careful to make sure that that 1/2 gets distributed to everything. It's talking about all the terms inside that log, or along with that log. So you would have 1/2 log 8m squared plus 1/2 log n to the 6th. So it would be okay to do it that way as long as you realize that you have to keep that half with both parts of the problem. When you break it up with that plus sign, then the 1/2 goes along with both. And you can see now that if I take this 2 and move it in the front here, and I take that 6 and move it in the front here, watch what happens when you have the 2 there and the 6 here, and I keep the rest of the problem the same, that 1/2 log 8m plus that 1/2 log 8n. What is 2 times 1/2? You end up getting that 1, which drops out of the problem right there, and the m is here. And what is 6 times 1/2? 3. And so you can see by looking at both answers, when we look and compare these two, that they are the same. So there is another way to do it, a little bit longer. You got to be a little more cautious of that half, but you do get to the same answer. So just thought I'd point that out for you. Okay, now I think we are going to condense logs. Let's take a look at what this next slide is. All right, F, condense or write as a single log. This is the opposite of expanding. So in your book, they're going to ask you to write as a single log. And when you do that, simply reverse the rules. So in example 1, this is going to be log base 4 6 times 7, which is really log base 4 42. That's all there is to that one. And then in example 2 here, we see that we are going to be incorporating the power rule. And Other than that, oh, and we've got some addition going on, which means we're going to have multiplication. We have subtraction going on, which means we will be doing division. So you can slow this problem down for yourself a little bit when you do it. And let's just do the power rule first. So let's do log 4 plus log 3 squared minus log 12. You notice I wasn't saying base this time? Do you remember if the base isn't there what it's understood to be? Did you say 10? Did I hear you say 10? You're correct. It's 10. 10 it is. So it's understood to have a 10 there. No need to write it, but each and every one of these has a 10. I'm only writing it to show you that there is a base there. It's understood to be 10. All right, what do we do with that plus sign? That plus sign, we're going to make multiplication. So now we have a log 4 times. Do you happen to know what 3 times 3 squared is? 3 squared is 9. And this means division. So we're dividing by 12. Almost done with this problem. We're ready to wrap it up here. Bring it home with log, log 36 divided by 12, and that means that this is log 3. Okay, if there's a lot going on in that problem for you, press the pause button, rewind it, take another look at it. Assuming that when we had all that information about expanding logs, that condensing was a little bit easier for you since you've already seen it, just reversing the process. All right, and now the last thing we need to talk about is the change of base formula. This allows you to convert any log to a base 10. Woohoo! We like this. Have you figured out why you like this yet? Think about what this means. This means you can use your calculator. You can use your calculator for these. But first you got to know how to do it. So here we go. I'm going to teach you that. Another way to write this log base 37, if I want to change my base, totally change my base, and I'm going to change it to a base 10, I put a log on top of a log, and the 7 goes up, and the little tiny 3 goes down. So the base, which is below the log, actually goes into the denominator. And it's kind of an easy way to remember it. Now you're just going to go to your calculator, use your calculator. If you don't have your calculator with you, of course, you can press the pause key. Go get your calculator, and we're going to just use our calculator, press log 7. And let's see what we get when we do that. Okay, when you use your calculator for logs, you really don't want to do this separately because the log, even though it's in a base 10, when you're evaluating a log 7, it's an approximated value. When you're evaluating the log 3, it's an approximate value. So you want the calculator to hold as much information as it can. So your sequence is going to be where you're going to go into your calculator and press log 7, then your division key, and do a log 3. That's all I need for you to do. And the answer when you compute it is 1.771247, and it goes on. In your book, they want you to round to the nearest thousand. That's the third place value right here. So that 2 will keep that 1 right where it's at. The final answer is approximately 1.771, and that is our answer. So again, keep that in your calculator, and when you do, you just got to estimate to the nearest thousands. I'm going to rewrite that so that we're clear about what the answer is, and it's approximately 1.771. That's the answer. Okay, I think I have a U-try for you here, so let's take a look at what you got. Let me slide that down for you so you can see it. Here's your U-try. Go ahead and do that. Come back to me when you're done. See if you got the right answer. Okay, so So you went to your calculator after you separated it and you had a log 2 on top, log 6 on the bottom, and you should get the answer of, and the answer is approximately 0.3868, which rounds to 0.387. Now, if you've got an answer of 0.409965, you need to be real careful when you're using your log functions, your log button on your calculator, that you close out those parentheses right after the log, and that's the reason why you got the wrong answer. We can talk more about that calculator work tomorrow, so I think that's it for today. We are at the end, so good luck with that and understanding everything, and we'll talk more tomorrow, and see you soon.